Alright, we're going to be calculating volumes by using a method of washers. But specifically in this video, we're going to be revolving our shape that we're going to get from this around the y-axis. So make sure you know how to revolve a shape around the x-axis before revolving it around the y-axis. It's much simpler, more straightforward, but as you'll see, it is exactly the same, essentially. So here's the question. The region bounded by the parabola y equals x squared and the line y equals 2x in the first quadrant is revolved about the y-axis. Find the volume swept out. So if you're having any trouble visualizing this, you're thinking about this region that is being generated essentially between y equals x squared and y equals 2x. So if we want to look at that, we can do it like this. Here is a plane. Make it look nice. And here we have y, and here we have x. Fine. Now we know we're looking at y equals x squared and y equals 2x. And we're trying to find the region bounded between these two. We know y equals x squared. I've seen it before. If you're doing calculus, you must have seen it. So y equals x squared. And the line y equals 2x, which I'll just quickly draw. You know, it's kind of going to be a straight line, something like that. Steeper, less steep, whatever, doesn't matter. This is just a rough drawing. This is y equals 2x. So it's asking for the region bounded. That would be right in here. And what we're going to be doing with this shape is we're going to be revolving it around the y-axis and essentially creating a bowl, if you could think about it, with like a triangular center in it. Excuse me. So this is kind of the fundamental idea of how you're going to start every one of these problems. Draw it, understand what you're looking at. And another key point here is to understand what points you're looking at. Where is this bound? Well, we know this is 0, you know, and we can find out what this point is here. Well, we can find out where they hit each other by setting them equal to one another. So if you do this, you know, just basic kind of algebra here. So, you know, x is equal to 0 or 2. These are the 2 points where these guys are going to hit, and here's 0 and here's 2. So, you know, we're looking at 2 here. The other thing you can do is you can plug this back in and find out what the y coordinate is, and we know that this is going to be 2. And as you can tell, 4. So that just gives us an idea of what we're working with. What is that region bounded by? Because, you know, you're going to need to know where these points are hitting, and you're also going to need to know, you know, along the y-axis, x-axis, whatever, if you're going to be writing an integral. Because if it's a definite integral, you're going to need to know where you're going to be integrating from. This is how you derive your a and your b from this formula right here. And this formula you just need to know. This is how you find, or you use the method of washers to get a volume. And it says that the volume is equal to the integral from a to b, definite, of pi outer radius squared minus inner radius squared with respect to x. Well, if you look here, a and b, which is where we're going to be integrating from, is going to be from 0 to 4. This is the region along the y-axis that we're going to be integrating from. Now, quick note though, as you can see in this formula, this is with respect to x, and that's how they generally give it. But that's not how we're going to be doing it, because we're revolving it around the y-axis, meaning that our small washers that we're going to be generating are going to be with respect to the y-axis. So let's see what we can do here. Just quickly write our formula for what we're doing. Volume is going to be equal to the integral from a to b, pi outer radius squared minus inner radius squared. Just remember this. Just get it in there. With respect to y. We're not dealing with x here. You're going to be integrating with respect to y. So, if we look at our graph, where are we going to be integrating from with respect to the y-axis? Well, from 0. And what's the tallest point? 4, according to the y-axis. So we're going to be integrating from 0 up to 4. And this is with respect to y. Fine, easy, whatever. And this pi right here, it's a constant, and as we know with integrals, you can pull the constant out in front. Fine, good. Well, now all we need to do is get our outer radius minus our inner radius. this is where the biggest mistake comes in setting these up, in my opinion, because you want to say that, okay, well, here's my axis, and as you might know from other problems, I'm going to go up, and this is my outer radius, and then this would be my inner radius. But that's a big mistake, because if we're revolving around the y-axis, everything is going to be in reference to y. Well, if I'm in reference to y, my outer radius is going to be y equals x squared. So our outer radius equals, is equivalent to y equals x squared. And then we're going to say our inner radius, we're going to be using, because you go from here to here, the inner radius, y equals 2x. Okay, fine. Well, what if we plug those into our equation? That'd be x squared and 2x, boom and boom. We have a problem. We're integrating with respect to y. This doesn't work. This is in terms of x. We need to put these guys in terms of y. Well, if you know how to put anything in terms of y, what you would do is you would square root this side, square root this side, and suddenly what you would have is the square root of y equals x. Okay, now we got it in terms of y. What about this guy? Well, you just divide by 2. So you'd have y over 2 equals x. Just saying it in terms of y. That's all you're doing. Well, now that I have it in terms of y, I can take my outer radius, square root of y, squared. Don't forget the squared. Always bring those guys down. And then this guy, y over 2 squared. Close it up. Fine. You're set up. You're ready to go. Honestly, you've done all the hard work. There's nothing left to do. Setting up this problem is the entire challenge of the problem. And that's what most teachers or problems are looking for. A lot of times teachers won't even say solve it, but most of them do. So volume is equal to pi. Going to be integrating from 0 to 4. Just keep bringing it down. That's how I like to do it. It usually works well. You kind of see where you're going. Make sure you didn't forget any of the squares. Well, we know this cancels out, so what are we going to have? Y. Easy. Minus. And, you can think of this in parentheses. This guy's going to come down here. This is going to come down here, and you get y squared over 4. Boom. And this is all with respect to y. Excuse me. So, let's integrate. Because that's what we came to do. If we're going to be integrating y, we know that this is going to become y squared over 2. Basic integration rule. Minus, and this is going to be y to the third over 3 times 4, which is 12. And all of this is going to be integrated from 0 to 4. Okay. Well, let's keep going. Just keep the train of thought going. And if you got to know about how to do definite integrals in order to do this. So if you don't know how to do them, go back and figure that out before you try and go any further. But if not, the rest is fairly simple. Do 4, plugging in the upper limit, squared over 2, minus 4 cubed over 12. And then we're going to be subtracting from that the lower limit, 0. So that's 0 squared over 2. And I think a lot of you know where this part's going already, right here. This is nothing that crazy over here. So that's minus 0, if you couldn't tell already. And then over here is the only kind of challenging, not challenging per se, but a lot of room for error. And this is where most of the mistakes are going to be made. And you're going to end up with 16 over 2 minus 32 over 12. Of course. Minus 0. Oh, and see, this is what's great about doing it like this. You can catch your mistakes. Don't forget the pi. That goes down for the entire ride. So the pi's there. And this is going to simplify, if you do this, and I've already done it, so I already know, but it's going to simplify to 8/3. You still have your pi out there. This is still 0, and you're going to get 8 pi over 3. And you've just found the volume swept out of the shape. So the region bounded by the parabola y equals x squared and the line y equals 2x revolved around the y-axis. So there you go.